Hello and welcome everyone. Today I'll be teaching all about recursion, backtracking, DP and some more stuff in C++. So let's begin. So what is recursion? Basically a recursion is a function in which you call a function itself. So basically it goes for loop. So it goes in the loop in recursion. Now suppose you are asked, you have to write this. You have to write this using recursion. How do you think you'll do? Well, basically you have a function in which you pass a parameter n, and that gives you the output. Well, basically the output is I'll just see out n for now and line. So you can just write this function in this loop and then it will keep going for n times. So you can basically do that directly using recursion. We don't have to write a loop. So basically recursion is very useful. It's not just used over here but at multiple other places. So what recursion does, we can just write void function integer in and then cout n minus, no, not cout. First we can write the logic first. Suppose we write cout n end line. Then we need n equals from 1 to n. So what we'll be doing, we'll be using recursion above this. So we'll just call the function and reduce the size of n. So once you start reducing the size in the function, you will notice that this keeps calling the function again and again, which will help us go from n up until all to minus infinity if we don't write any condition. So if we write a condition, if n double equals 0, we can return the function. So this will just go from n to 0 or n to 1, I can say, because at 0 we are returning. So next what we can do, we can write some complex logic over here. So first let me tell you about recursion tree so that you can find out the time complexity yourself. So basically what is a recursion tree? A recursion tree is basically, you just take some example. Suppose you take n over here and then you write the function interior as you want. So basically you go from function n to function n minus 1. So we called n minus 1. Now when function n minus 1 is called, it will call for n minus 2. So now notice that this gets called, this part is yet to be called. So function n minus 2, so function n minus 2 is called because n minus 1 was called over here and then we had function n minus 1 again. So our n changed to n minus 1 and we did n minus 1 again, which is equal to previous n minus 2. So we have, or I can write this as new n equals n minus 1, and then we have new n minus 1 equals previous n minus 2, or I can write just as n minus 2. So basically our new n is n minus 2, and then we can do that again and again. So basically it will go until we have defined a condition. So basically here we define the condition, if n double equals 0, return. So at 0 it will return the value. Let me first write 1 over here and then 0. This is our basic recursion tree for, you can say, unidirectional recursion. Then we have this, it will keep calling other stuff if anything is left. So anyone can guess why this keeps calling even if it has returned the value? So basically what happens in the backend, we are calling a function, okay? So once it calls up till this block of code, this line of code, it notices that after returning, there were some stuff that wasn't called. So it will start calling one by one in the backward order. So from 1 to n, it will call all the numbers. That's how function works. So suppose if you were writing something else over here, suppose it was function x over here. You just write x equals n minus 1 and then you can pass x over here. That will also do the same stuff. So basically, long thing short, you can just remember that this calls friend. Basically, if you want to go in straight order, forward order, forward order 1 to n, you call for n minus 1, and for backward order from n to x, you call for I plus 1, or you can say x plus 1, or whatever you choose. Basically I'll choose I plus 1. N to I. So I'll be giving you a question now. Write a recursive function where you print the value from x to n, both inclusive. So basically this is your question, homework question you can say, or you can say practice question, because I will be solving it right here. So first let's check this code and then we'll be moving on to this. So first we have to write a function, a void function, basically void func, or let's write that recursion so that you remember. So basic recursive function is, you can just write integer n, and then what you can do, you can just write if n equals 0, you can return, otherwise you have to write the logic. Not func, this was a recursion, and we don't have to return this for now at least. So we have, okay, so we have about cout. So you just have to remember this recursive tree. Basically it calls for n to 0, then it checks that at 0 we have ended everything, so it tries to go back in this. So it basically takes n square, order of n square. Basically its time complexity is n square. What about its space complexity? Basically for void function we don't have any space complexity, but yeah, in the console it will take 4 bits each, so you'll have we will have 4 times n memory memory capture. Well, basically not optimization because we didn't optimize anything. Anyways, let's write over here. It should give us from 1 to 8 in forward order. Basically in ascend, so in ascending order. Now you can change the logic as you want. Suppose you don't want end line to be over there, you just write this. Remember that you have to use recursion only in crucial stages. Basically, most of the time you will be using DP. Basically, DP is much better version of recursion. You can say it's optimized version of recursion. Anyways, the second topic, write a recursion function where you print the value from x to n. Both are inclusive. So first you have to check whether you can write. Okay, so we can't write void. Okay, we can void function. We have to take value x and n. Then what we can do? Okay, so let me first write the logic. Then we'll be writing the condition over here. You can leave the space for condition always because you can break it over either over here or over here. So we have condition, we have some condition. Now suppose if you have to write from x to n, what do you think we will call? So you can basically call for function where you will be updating values like x and n. So basically in my case, I'll be just updating the value of x because because there are two ways to write this, but I'll be choosing the most optimized way. Basically where we just have to change one variable. Otherwise if you change both the variables, then time complexity changes and you might get optimized or de-optimized version depending on your code. So function x plus 1 command. So from here we have all the function. So since it was going to call x plus 1, x plus 2, x plus 3 up till x plus n minus x. So for this we need to have it up until n minus x. So basically if x double equals n, well let me check. This will give us, okay, so we just have to print out x over here and then we will just yx because you are changing x. So if you want to get something in a recursive function where you print the value from x to n in reverse order basically. So we can just state this if you want in reverse order. First we'll be doing this in reverse order, then I'll be telling you how to reverse an array. So once we are used to reversing an array, we will just combine these two, then we'll get our this question's output. So basically from x to n you just have to basically if this was the question, then I can just change it directly like this. N minus 1 f n equals x return. not x, x minus 1. Then we can return. So basically we can do it just directly like this. But I thought we had to do it a reverse order because I had that in the question in my module over here. But since I changed the question, I believe this should be the stuff that we should write. Anyways, since n double equals x and there is well actually let's take 3. It should give us the output from 3 to 8. Basically 3, 4, 5, 6 and 8. Okay, so we didn't have okay, so this was x minus 1. Why x minus 1? So that we can get the x value in this. Yeah, so basically that was the case. So this question was easy. Let me write a better question. So write a recursive function. Write a recursive function for printing the values from x to n in reverse order. Without using, or I can say where you can use only two parameters n and x. So now you can write the question. Sorry, solution. You can write the solution now. So write a recursive function for printing the values from x to n in reverse order. Remember that you have to write this in reverse order. So where you can use only two parameters n and x in the function, in the recursive function basically. So you have to print the values from n, n minus 1, n minus 2 till x in reverse order. So basically this should be the order for your output. Okay, so if you can solve it at under 10 minutes, then it's well and good. If you can't solve it at under 5 or 10 minutes, then you can just come back and rewatch and watch the solution. Okay, if you are done trying, then let's move to the solution now. So basically we can just remember that we have to first write the logic. So I'll be calling function or recursion, what we have a recursive function from n to x. Okay, so let me first tell you the logic, then we can write the code. So basically we have, yeah, so let's continue. Well, actually I got some call. Yeah, so I was at, what was the question again? Write a recursive function for printing the values from x to n in reverse order. Okay, so we have to write this in reverse order. So basically we'll have two inputs, x and n, or parameters you can say. So first we have to go from x to n, basically so that the recursion can follow from n to x, and then we can just directly print that out. So going from x to n means we have to just increment the size of x and then break it at and return function at n minus 1. So this is how you build a recursion logic. You have to think in which direction you have to go, and then if suppose you have to go from x to n, you just keep increasing x, value of x. Well, since we had, well, let me just first finish this quickly, then I'll be explaining you some other logics. So x plus 1 we have to do again and again. So basically we'll go from x plus x, x plus 1, x plus 2. By the way, both are inclusive over here. X plus 3 all up until x plus n minus x. So we have written the function at at n plus 1. Why at n plus 1? So that the function can get value at n and it. Basically, we'll be returning the function if x is equal to n plus 1. So basically this is the case, and then once we are done calling the function, x plus 1 and up until function n, then it will call these functions in the reverse order. Then that will be n minus 1, n comma n minus 1, n minus 2, n minus 3, n minus 4, and so on. So on up until x. So we have to write a single condition for this. First we'll be changing the value of x, and we'll be printing the value of x. So basically most of the time, or you can say always, you change or you print or you try to do any logic with the value that's been getting updated. So if if x is getting updated, so you have to use x over here for the logic. So in our case, our logic is so simple that we don't have to worry about that. So suppose if x double equals n plus 1, return. So after returning, we'll just call this function. Basically, I'll be printing the value from 10 to 5 in reverse order. Basically, 5 to 10 in reverse order. So we'll have 10, 9, 8, 7, 5, 6, 5. Yeah, so we had 10, 9, 8, 7, 6, 5. So basically, what you have to remember from here, that if you want to go in forward order, you'll just use n minus 1 logic. And if you want to go in reverse order, you use the logic I plus 1 or x plus 1, whatever you prefer. Well, let me write it x plus 1. So you use the logic x plus 1 till x equals n minus 1. Sorry, n plus 1 till n equals 0. Okay, so you have to remember these two for now. Next, we have factorial. We are already past 20 minutes. Let me check what is the time. Okay, so will it be good if I explain recursion in detail? So I believe for explaining it in detail, I'll be taking few more lectures. Suppose I'll be taking 5 more lectures or 4 more lectures on recursion. And then we'll go to backtracking. Then we'll be moving to DP, then bits and bit masking. And after that, we'll be moving to sorting algorithms. So first, let me write the topic already. So with sorting algorithms, we need some, you know, functions inside the main function, basically comparators. So I'll be teaching you all about lambda expressions too. So lambda expressions, and what do we have? And next we have sorting algorithms. Well, actually, I made the planner, but I lost it in between because I didn't want to go that low level. The planner was actually very bad, so I had to I had to change the planner by myself, or you can say rewrite the planner. Anyways, thank you for today. We'll be meeting tomorrow again. Well, basically not tomorrow. I'll be uploading 2 videos a day. So we'll be meeting at 7 of both the time. Basically in 12 hours we'll be meeting at 7 and 7 in a day. So yes, that's it for today. Next, we'll be meeting at 7 next. Thank you everyone. Thank you. Take care. Bye bye.